Okay, let me show you the contents of this video which I am going to cover. First, I will explain about the face image database that will be used for this problem, and then I will talk about the image database preparation for training and testing. And then I will talk about how to find the wavelet features that will be utilized to recognize the faces. And then I will talk about the principal component analysis for dimension reduction of this feature vector. And then I will talk about the training and the testing procedures, and then I will explain the Matlab code which is written for training, and then I will explain the Matlab code for testing, including both discrete and the bulk testing. So let me go ahead, but before that I recommend you to watch following these two videos. The first one is about the principal component analysis for images and signals. So here I have covered the basic theory of PCA, and I have shown its implementation for images and signals. So if you go through this video, it will definitely help you to understand the current video, because I have taken or used PCA directly in this current video. And the second video is about the face recognition using PCA in the Matlab. So here I have implementing the basic framework of face recognition utilizing the PCA. So this video will also help you to understand the current video. So now let me start this session. So first let me tell about the database. So here I'm going to use the Faces 94 database for face recognition. So this database you can obtain from following links. The third one is from my own website, that is exptech.co.in. Okay, and these links are also given in the description. Now let's see what is inside the database. So in the database we have actually the total 153 persons, and 20 images per persons are given. The resolution of image is 180 by 20 pixels in portrait format. And if you unzip this, when you download, this will be in the zip format. So when you unzip it, you will get the 3 folders by the name female, male, and the male staff. And these are the number of persons which are included in following folders. I mean 20 females are there and 113 males are there. So here are some samples of these face images from this database. So you can see these images are frontal face having the common background, green background. They have different face postures, and they have the different lighting conditions also. So now let me show you the preparation for training and testing. I mean what changes are required in this database. Actually, as I said, there are 20 images per person in the database. So out of these 20 images, I'm taking 16 images per person for training. Okay, and instead of lots of people, I'm just considering only the 50 persons. So for 50 persons and 60 images per person, there will be total 800 images, and that will be utilized for training. And for testing, remaining 4 images, I mean out of the 20, 16s are taken already for training, and the remaining 4 per persons, 4 images per persons will be utilized for testing. So for 50 persons, definitely they will be the 4 into 50, I mean the 200 images, and these images we will not consider for training. Okay, and the size of image, as I said, it is 180 by 200 in database, but I have noticed that few images are found to be of the slightly different size. There is a slight mismatch of few pixels. So be sure before getting the feature or feature vector, please resize all the images to a common size. So I have taken total 1000 images. I mean 800 for training and 200 for testing in the same folder. And this is the folder. The name of this folder I have kept face database. You can give any name of your choice. Okay, so now what you have to do next, the name of the images in the database are of different format. Okay, so to apply the or to run my code, you have to do this a small work. First, you have to rename all the images in this way. That means 1.jpg, 2.jpg, and so on till 1000.jpg inside that folder. Now, how to do this? This is simply achieved by the batch processing, and that batch processing can be performed using some third-party software such as Irfan View, Format Factory, etc. The Irfan View is a free software you can easily download from the internet, and it is of a very small size and very quick. And those who are expert in the Matlab, they can also do the same thing by writing the script in the Matlab. But I recommend Irfan View. It is a very simple to rename all the files like this 1.jpg, 2.jpg, 3.jpg till 1000.jpg. Okay. So all Matlab script files, I mean all programs which I have written, those programs must be saved inside this folder. I mean the same folder. It carries all the 1000 images, and it is also carrying these all the Matlab scripts which I have written. So I have written total 4 Matlab scripts for this purpose. The first one is the dbtrain.am. This Matlab file will be utilized for training part, and then discrete testing. This will be used for testing your performance of the program. But discrete testing means you can give one image at a time, and you can retrieve the relevant or nearest matched images. Okay, so you can test one image at a time. So that is a manual testing sort of things. In bulk testing, actually you will test all the files. You will read automatically all the files, and their results will be displayed. So suppose there are 200 images for testing, so it is not possible with this file. That means you cannot do manually for all 200 images. So you have to run this program. So it will automatically read all 200 images, and it will display the recognition result. And this is one function file that will be utilized by this bulk testing.m. Okay. And the prepared database is also available on my website. So you can visit my website and you can directly download this database, which has the files already named with 1.jpg, 2.jpg, like that. Okay. Now let me show you that database in my computer, so you will have the idea. So let me jump to my directory. Okay, so this is my current working directory, and here you can locate this folder. That is a phase database. So let me show you inside it. Okay, so these are the images starting from 1. So you can see that this is the 1.jpg of size 180 by 200. So these are all images up to 800. They are training images. I mean up to here 800. So these are images that will be used for training, and from 801 till 1000.jpg they will be used for testing. Okay, and all my 4 Matlab scripts are here. You can see the bulk testing, dbtrain, discrete testing, and then phase recog function file. So you have to do this in your case also. Only then this code will run. So you have to store all the 1000 images and these 4 scripts in the same folder, right? So now let me return back. And now let's see how we can find the wavelet features. So that will be utilized for recognizing the faces. So this is the overall scheme. You have your input image, which is the RGB color image of size 200 by 180. First you have to binderize this image. Okay, so when you binderize this image, you will get the binary image like this of the same size, and then you have to take the discrete wavelet transform, one level discrete wavelet transform using the db10 wavelet. So after taking this, you will get these 4 matrices. CA, CH, CV and CD. CA represents the approximation coefficient matrix, CH horizontal detail coefficients, and CV actually representing the detailed vertical coefficient matrix, and CD the diagonal detail coefficient matrix. Okay, the size of these four matrices are actually the half of the size of image. I mean the 100 by 90. Okay, and now I have placed or appended these matrices side by side like this to create this matrix WC. So this matrix is known as WC matrix. So what will be the size? Obviously this is 100 and this is also 100, so it is 200, and 90 and 90, so it is 180. So the size of this matrix is same as of your image, 200 by 180. Now to extract the features, what I am doing here, I am taking the standard deviation of these wavelet coefficients. So I'm taking the row wise standard deviation and the column wise standard deviation. So since there are 200 rows, taking standard deviation of each row, you will get the 200 values, and I am storing those 200 standard deviations in this variable std row. Similarly, I'm taking the standard deviations of all 180 columns. So I'm getting those standard deviations and I'm storing those 180 values into this std col variable. Then concatenating these two you will get a combined feature vector of size 380. I mean 180 plus 200, you will get a single array. Let's say the name of this variable is FVSTD, feature vector of standard deviations. So that will be utilized as the wavelet feature vector. So now what you have to do, you have to represent all the images in the training database, I mean the 800 images, into the corresponding wavelet features. So now the size of this wavelet feature vector is 380. Although it is not too big, it can be utilized directly, but to make the system faster, okay, and if you want the less memory requirement, this has to be reduced. Okay, so to reduce the dimension of this 380 point vector, I'm utilizing the PCA. So PCA is well known for dimensionality reduction. So here I am projecting my 380 point feature vector, wavelet feature vector, to the PCA space with this formula, and I'm getting the reduced size feature vector. It is of only the 70 points. Okay, how 70 points? Actually the 70 is the count of the dominant eigenvalues, I mean the most significant eigenvalues which I select in this process of doing PCA. Okay, you can reduce to the further values. I mean you can go below 70. It is not necessary to keep it 70. Empirically I found 70 is giving the better result. So if you can go to 60, I think it will also give the better result. Okay, so you can go below to a value till you are getting the acceptable results, right? So in this mapping equation, this is your input feature vector of size 380, and its size is given, that is 1 by 380. M is the mean of all the feature vectors of all 800 images. Okay, so all 800 images are converted into their corresponding feature vector, and then taking mean of that, that is the M represented by M. So its size is also 1 by 380. PCA is a transformation matrix, and its size is 380 by 70. And then using this equation, obviously the FVPCA is your reduced feature vector, and its size is 1 by 70. Okay, so now let's go for the training procedure. So this is the training part. So what you have to do, you have the total 800 images in your folder. You have to read all the images. You have to take the wavelet transform of that. I mean you have to find the wavelet feature vector by the method which I have just shown you in the previous slide. So you will get the FVSTD, I mean the feature vector, whose size is 380. Okay, so that's why you can see the 380 size is written here. And here I have created a matrix X whose size is 800 by 380. 800 by 380 because total 800 images are there, and the size of feature vector, each feature vector is 380. So all the 800 images are converted into their corresponding feature vectors, wavelet feature vector, whose size is 380. So since size of X is large, it is 800 by 380, so it will require the more memory, and for searching definitely it will require more time. So to get the faster search and to have the less memory, what I am doing here, I am utilizing the PCA to reduce its size. So I am projecting this matrix to the PCA and I am getting the reduced size matrix. So here the X is transformed to the matrix T, whose size is only the 800 by 70. 800 will remain 800 because the number of images are 800, but the 380 size is now transformed to the 70. And how the 70 is chosen, as I already said, by selecting the 70 most significant eigenvalues in the process of PCA, dimension reduction. So this theory you can get in my previous video of the PCA, which I have suggested to watch before this video. So now let me go for the testing. Testing means finding the nearest match. It is very simple. So this is your query image. You want to search its nearest matches in the database. So first you have to find the wavelet feature vector whose size is 1 by 380. So now projecting this 380 size feature vector to the PCA, it will reduce it to the 1 by 70. So let's say this 1 by 70 is represented by the FVQ, that is the query feature vector. So now I have to match this FVQ with the previously stored 800 feature vectors, which we have just obtained by applying the PCA on all wavelet feature vectors of those 800 images. So this is one-to-one match, sequential match. So it will be matched with this first, second, third, like that, and we are getting the similarity on the basis of the finding L1 distance. So L1 distance is the simplest one, which you can find like this. So obviously the best match will be one where you get the least distance between the two. I mean FVQ and FVPCA. So suppose my best match is found with this image. So what is the index of it? So this is first, second, third and fourth. So this is the index number 4. Okay, so with this index, I will search my image database and I will simply display the 4th image as the nearest image with this query image. So it is very simple procedure. Okay, so now let me come to the programming part, how all these things are implemented in the Matlab. So this is my first script, that is the dbtrain.m, that will be utilized to train those 800 images. So what I am doing here, n is defined, that is the number of training images, n equal to 800, l equal to 70, that means the number of dominant eigenvalues selected. Here I am selecting 70. As I said, you can try this for even the lesser value. For the lesser value, let's say go for 60, 50, and then check the accuracy of the this scheme. And here I'm defining the size of the image, that is 200 and by 180, and then I'm defining or initializing the X matrix. So as I said that this is the matrix of 800 rows and 380 columns. So that will store all the wavelet features of all 800 images. And inside this for loop, where I have started a counter that will start from 1 to 800 and then reading all the images one by one. Okay, so the first image is 1.jpg, so that will be read here. Then after, as the counter increases, this count will increase to 2.jpg, 3.jpg, like that till 800.jpg. So all these are my training images. So I'm reading all the images one by one, and then since these images are RGB images, so I'm converting them into the grayscale, and then I'm resizing because as I said, the few images in the database are not of 200 by 180, they are of slightly different in size. So to ensure all images to be of the same size, I am doing this step. And then with the I am binderizing the image, which is required for finding the wavelet features, as I have discussed. And here in this section, I am finding the discrete wavelet transform of that image, one label DWT with the wavelet DB10. So I'm getting these 4 matrices, and then I have arranged these 4 matrices like this: CA, CH, and CV and CD. So that is a single matrix. So that is WC of size 200 by 180. And now I'm taking the standard deviation column wise and then standard deviation row wise. So I get these 2 variables, std col, std row, and then concatenating these 2 arrays, I'm getting the feature vector, wavelet feature vector of size 380 points, okay, 200 plus 180. And then I'm storing this feature vector into the X matrix. So in each row, I'm storing this feature vector for each image. So this matrix I get of size 800 by 380, right? So this part is complete here after the for loop. So what I'm doing here, I'm just converting all the 800 images into their corresponding wavelet feature vector. That's it. Now my aim is to reduce this matrix. So its size is 800 by 380. I want to reduce this to the T matrix of size 800 by 70. So this is done by PCA. So in the next section, I am implementing the PCA. So first I am finding the mean of all the feature vectors. So that is the M, and then subtracting all the means from each feature vector. So I'm getting this modified X matrix, then finding the covariance matrix. Actually all these theory is well explained in my previous PCA video, so I strongly recommend you to visit that. Then you will be able to understand this code, okay. So then once the covariance matrix Q is found, I get the eigenvalues, I mean the lambdas and their corresponding vectors, eigenvectors. Then extracting all the eigenvalues, I mean all the lambdas in eval, and then sorting those eigen values, lambdas, okay, in descending order. That means keeping the highest lambdas in the beginning, right? So these will be your dominant lambdas. So out of these all lambdas, I am just selecting the 70 lambdas, I mean 70 eigenvalues. So this is what I am doing, and for these chosen 70 most significant lambdas or eigenvalues, I am getting those corresponding eigenvectors. Okay, so this is the matrix PCA, which has the eigenvectors only corresponding to these selected most significant 70 eigenvalues. So this is the reduced matrix. That's why I have written reduced transformation matrix. So with this matrix, when multiplied with this X matrix, you get the reduced matrix T. Why? Because X has the size 800 by 380, okay, multiplied with the PPCA, and PPCA size is 380 by 70. So 380, that means 800 by 70. So you will get the reduced matrix 800 by 70. Now I am saving a few workspace variables in a .mat file, wpcadb. So this will be saved in your current directory. So I am saving the number of training images, mean, image size, and this PPCA and this T matrix. Okay, so these will be utilized in testing. So I have written a note. Please change the above path as per your working directory. This is in my laptop. Okay, in your laptop, if you are working in, let's say, D directory, so it will be D. If you have given some another name to your folder, it will be there. So change according to your current working directory and the name what you have given to the folder. So now let's come to the testing program, that is the discrete testing.m. Here what you can do, here you can test one image at a time. So you will select a one particular test image and you can find the 5 nearest matches of that test image. So what you have to do, first you have to load those saved variables in the file wpcadb.mat in that same directory. Okay, so this file loads these variables m, n, small m, and ppc and t. All these will be utilized in the recognition process. So with this line, I am just reading my input image from the current directory. I can pick with the UI get file, a system dialog box appears from where you can select any of your file that you want to test. And then copying this image to another variable that will be used later for display purpose. And now since the input image is the RGB image, so converting into the grayscale, resizing it, and then binderizing it. So this code is same exactly what I have written in the training file. Okay, and then taking the wavelet transform of the image, getting these 4 matrices, coefficient matrices, approximation, horizontal, vertical, and detail, diagonal detail coefficients, and then arranging these matrices like this to form this WC matrix. Then finding the standard deviation column wise, row wise, and then concatenating these two to get this wavelet feature vector. So this FVSTD of size 380 is obtained like this. Then you have to reduce it in the 70 size. So this mapping equation is utilized. So here you will project your 380 points to the PCA space to get the 70 points. So its size is 380. M is also 1 by 380. 1 by 380. PPCA is 380 by 70. So obviously FVPCA you will get 1 by 70, right? So this is your input query image that is now converted into the 70 point feature vector. So this 70 point feature vector will be compared with all previously stored 800 such feature vectors in the matrix T. So here I am initializing the distance array. I will calculate the L1 distance with each previously stored feature vector, and then finding the L1 distance. Very simple, simply absolute difference, element to element difference, and then having absolute sum and storing in each location of this distance array. So once this all L1 distances are calculated, now you can sort. You can do the sorting. The sorting means the least will be at the first location. So least will be at the first location, and it is in ascending order sorting. So obviously for the first 5 matches, we have to read the first 5 indices in this array. So I am reading the INDX, the indices of the return value of the indices in the first 5 locations, and then reading the images from the database with these indices. So the nearest matches will go into these corresponding 5 variables, and then displaying or showing these images. So this is your input test images, and this is the first match, second match, third, fourth, and fifth. So you will get the visual display of these nearest matches, right? So this is the discrete testing. That means you will give one image at a time as a input. Now suppose you have the 200 images, as we have in this case also. So how to check the accuracy of this proposed scheme? So obviously you have to test all the 200 images. So manually it is not possible. So I have written this program. So that is the bulk testing.m. So in this bulk testing.m, this program will automatically read all the 200 test images and will find the corresponding recognition result, right? So first you have to load that .mat file to get these variables which are needed. So defining the number of persons 50, number of training images 800, number of test images 200, and then P, that is the NTE upon NOP, that means number of test images per person. So obviously it will be 4, right? 200 upon 50, and then Q NTR upon NOP 800 upon 50, that is 16. So number of training images per person are 16. K equal to 800, it is actually the counter which is set for looping. Actually from 1.jpg to 800.jpg. So these are your training images, and from 801.jpg to 1000.jpg, these are the 200 test images. So I am setting one counter at point 800.jpg. So what is it? Start of the counter for test images -1. I mean it should be at 801, but I'm setting at 800, I mean 800. So this is the counter, and this is another counter, L equal to 0. So it is counter for train images -1. I mean in place of here I am placing at the 0 position, I mean this L equal to 0. Okay, so this is one counter which will be utilized for training images, and K is the counter that will be utilized for testing images. And here I am initializing an array by the name flag, which has the size equal to the number of test images, I mean the 200. This flag array will accommodate the outcomes. I mean if I choose the image from these 200 test images, then if image is correctly recognized, face is correctly recognized, then we will store 1, and if it is falsely recognized, we will place 0, like that. So this flag will have only the 1 and 0 values, 1 for correct recognition, 0 for false recognition. So here I have some loops. So my first loop is for from k plus 1 to k plus v, I mean from 801 to 804, because these are your test images from 801.jpg to 1000.jpg, right? But as I said, there are only the 4 images per person, 4 images, test images per person, from 801 to 804. So this loop is from 801 to 804 for first person, right? First person. And I'm reading these images one by one, and then getting their corresponding indices from the recognition. So this is a face recognition script or function which takes these values, I mean your input image and these parameters that those are required for recognition. So I get the corresponding index number, and now how I am checking whether it is correctly recognized or not. Actually here I am checking that if I is between 801 to 804, I mean the input is these images, then output return index must be L inside the range L plus 1 to L plus Q. The L is 0, so that means it is 1 to 16, right? Why 1 to 16? Because these first 4 images are of first person, and in the training database, which starts from 1.jpg till 800.jpg, okay, the first 16 images up to 16.jpg, they are related to the first person. So first from 801 to 804 are related to the same person, and from 1 to 16 in the training are related to the same person. So what I am doing, if my input index is in this range, and if output index is from 1 to 16, it means my recognition is true. Okay, so I set the flag 1, otherwise I set the flag 0. So this is for first person. Now as loop is progressing, these counter shifts. So the L counter shifts from 1 to 16, all are covered, then it starts from 17. And then this K counter now shifts to 805. So it will read 805 to 809, and then it will check from 17 to 32, like that. So when all loops are finished, all the corresponding outcomes will go into the flag. And then how to check the accuracy? Simply counting the number of ones, I mean the true outcomes, okay, and divided by number of test images. So I have given 200 test images, so I am just counting the number of ones, I mean correct recognition. So simply division of these two will give you the percentage accuracy, right? So now let me show you what is inside this face recog function, which I have just used inside the bulk testing.m. It is simply again the same code. I am reading the image, converting RGB to gray, resizing, and then binderizing it, taking Wavelet Transform, getting the Wavelet coefficient matrix, and then having the standard deviation row wise, column wise, and then finding its 380 point feature vector, then projecting this to the PCA space, converting it to the 70, then initializing the distance array to find to store all the L1 distances, and then comparing this with all the previously stored 70 point feature vector of each image, and then finding the minimum of distance. That means the least distance means the maximum match, the best match. So I am getting the corresponding index. That's it. So these are the very simple programs. Now I will show you how we can run these programs and what type of output we will achieve. So let me jump to the Matlab, and this is my Matlab editor. So all these 4 programs you can see. This is the DB train, okay. This is discrete testing.m. This is bulk testing.m, and this is the face recog.m function file. So first I will train this. Let me show you the Matlab main window. Okay, so no workspace variable here. So I will simply run it. So pressing this run button, it will take some time. First time it takes time. Once the variables are loaded, it runs quickly. Okay, it is done. So you can see that all the variables are created in the workspace. So training part is complete, and now see the directory, this folder, and you will see that all those required variables are saved as the mat file. So you can see that this one is the .mat file by the name wpca-db, which I have also mentioned in the program. So it carries only those required variable, workspace variable, that will be used for testing purpose. Okay, so now come back. Now let me run the discrete testing. So this is the program of discrete testing. So I will run it, and it asks me to choose my testing image. So these images from starting from the 1.jpg, these are training images. Okay, so you should not choose any image which is already taken in the training, because it will definitely be the correct recognition. So we have to choose any image after 800. Okay, so from here you can choose any image till 1000. So let me choose this 801. This is the first test image. Open it. and this is the output. So you can see that this is your input image, and this is the first match, best match, second match, third, fourth, and fifth match. You can see that this is very dark image. I mean, the light is very low in this case, but still it is working good with 100% correct recognition. Now select any other one. Let 871 image, and this is the output. So input image and all the 5 best matches, and you can choose any one of your choice. Okay, let me choose this this one, 964, and you can get again the 100% accurate result. Okay, so this is the discrete testing. But to test the accuracy, I cannot do this 200 times. So I will go for the bulk testing. So I will run this program. Okay, so before that, let me show you the command window. It is clean. Now let me run this, run. So it is running, and see the command window. Okay, so here you can see that percentage accuracy is 100. So in this case, my program is working perfectly, giving you the 100% accuracy. It means all the faces are recognized correctly, right? Now let me show you the robustness of the proposed scheme. Robustness means if there are distortion in the test images, can this program recognize them? This happens in the real life also. Suppose some person has given his face data with a clean shave, and after some days he comes with a grown facial hair such as mustache and beard. Can this program recognize his face? If some lady does heavy makeup, or he or she puts goggles on face, can this program recognize? So let me show you the robustness of this program. So I'm just running it. I'm in the discrete testing file, and then choosing these distorted images. So these test cases I have prepared, where I have given a white scratch on the face, and then added some noise, and then distorting this background, and putting these goggles on her face, and then heavily distorting this face image. And in this case, I have put this artificial mustache and beard. So I will take these test images one by one. So I am first selecting this white scratch image, and let's see the output. Okay, so even this big scratch, in the presence of this big scratch, I'm getting the correct recognition. So these are the first 5 nearest matches. Now take one more case with this artificial goggles on her face, and again I'm getting the correct recognition. So this program is quite robust. So if a person comes with the goggles, without goggle, it can recognize his or her face. So take one more example with this background distortion. So again, there is no effect of the background distortion. And then one more example where I have heavily distorted this face image. So this you can see that this image is heavily distorted. That means it may happen because some transparent media is present in between her face and the camera. Still is able to recognize correctly. And then take one more case. Here I have put some white pixel noise. Still it is recognizing correctly. And then one more example of this person who has now grown the mustache and beard. Okay, so during the training, this image has no mustache and beard. I can show you during the training, this person is clean shaved. Let me show you where he is. Okay, this one you can see from 353 to 368. So this person is a clean shape, but now I have put the artificial beard and mustache, and let me show you the output. Okay, so it's still I'm carrying the 100% correct recognition. So these are quite practical cases which I have covered. So in all these distortions or change in the faces, my program is still able to recognize that person correctly. So this proposed scheme is quite robust. So that's it for this video. In the next video, I hopefully will try to implement the real-time recognition of these faces. Okay, so that's it for this video. I hope you have enjoyed it. So I really thank you all for watching this video and sparing your time, and have a nice day.